Buildings. You're probably watching this video while inside of one. And like many devices in our modern lives, we want to make them smarter. But to make smarter buildings, we need data. Most buildings, smart or not, already have things to detect temperature, humidity, motion. The thing is, these sensors are probably already communicating independently with completely different communication protocols. So it's tricky to get them speaking on the same page. That's where Streamsheets comes in. I'll show you how with Streamsheets you can aggregate multiple data streams into a single dashboard, even if they're speaking in completely different communication protocols. I'll also briefly show off Eclipse Zephyr as a real-time operating system for microcontrollers, and Eclipse Lesson for lightweight M2M servers. So the plan for the demo is to have Eclipse Zephyr running on our Featherboard, and our Featherboard will collect temperature and humidity data via our DH22 sensor. We're also going to set up a lightweight M2M server on our Raspberry Pi using Eclipse Lesson. The Featherboard will be acting as a lightweight M2M client and will communicate the sensor data with the lightweight M2M server through Bluetooth. From there, the sensor data will be exposed as an HTTPS stream from the server, and Streamsheets will be able to consume this data stream. I'll also show how Streamsheets is capable of taking in MQTT messages, and it's able to consume both HTTPS and MQTT data simultaneously. From there, we can play with the data on the Streamsheets app however we want, and we can have both the MQTT and HTTPS data on the same dashboard. The hardware for this demo is a Raspberry Pi, an Adafruit Feather NRF52840 board, a J-Link external programmer, and an adapter for the J-Link to the Featherboard. We are also going to need the DH22 humidity and temperature sensor. Okay, so on our Raspberry Pi, we're going to want to set up our Lesson server. We're just going to be using the demo server actually. We're going to use the Eclipse Lesson demo server. It's fairly easy to install. You just have to run this wget command. I already have it installed, but I'll do it anyways. And to get it up and running, we'll just have to run this. Again, the specific commands can be found on GitHub. Just going to run the server now. Okay, there we go. So it looks like the web server has started. So the server will automatically set up at the IP address of the Raspberry Pi that you set it up on. The port is 8080. Once you enter that, you'll see we're in. There's a nice little web UI for our Lesson server. And right now there's no connected clients. That's because I still need to set up the Featherboard as a lightweight M2M client. If you download the files from the GitHub, you'll find a file called lightweight the LWM2M underscore DHT. You're going to want to drag that folder into wherever you set up your Zephyr workstation, or wherever you set up your Zephyr workspace. And this code will just act as a lightweight M2M client to communicate with the server, and it will also collect temperature data from our DH22 sensor. So if you want to build it, again, the specific commands are on the GitHub. We'll hit west build. I've already built and compiled this to the board already, but I'll just do this anyways. You're also going to want to make sure that your J-Link is plugged in, you've installed the proper software that comes with it, and the J-Link cable is plugged into the header of the Featherboard. Once that's done, and you have the code all uploaded, so if you open up the terminal at whatever COM port you have your Featherboard plugged into, you should be able to see these messages confirming that the code is properly compiled. Lightweight M2M engine socket, receive thread started, initializing network. It's just waiting to connect to our server now. So if we go back to our Pi, and we open up a new terminal, We just have to connect our client. I'm just going to paste these commands. Just looking through the list of Bluetooth devices. The one that we're looking for is this one, lightweight M2M ISP node. This is the address, and we'll keep that in mind. There we go. Okay, so it might say address unreachable for a couple seconds, but now it's successfully connected. We're getting our pings here, and if we go back to our Lesson web server, we'll see our feathers connected now, and we have all this device data. Down here we'll find temperature and humidity. If we hit observe, we'll see we're getting 20.199. So that's the temperature in the house right now, and we have a humidity of 23.5. There's also room to implement light control if you wish. It is built into the web UI if that's something that you wanted to pursue. So right now I'm collecting all this data, and it's visible on our Lesson web server, but the question is, how do we get this connected to Streamsheets? Now we'll just head over to Streamsheets. I have this set up. So you'll see that this is our dashboard right now for our smart building web app for Streamsheets. Once you have Streamsheets installed, you can always access it localhost port 8081 on the machine that you've installed it on. So you'll see that I have 3 data values right now: temperature, humidity, and occupancy. Temperature and humidity are coming from our DHT22 sensor on our featherboard. You've seen me set that up with the lightweight M2M and Zephyr and all that. So I'll show you how I have that data being exposed right now. On sheets 1 and 2 are where I have temperature and humidity respectively. And it's very simple. I've actually set it up in this cell, but I'll show you again using the insert stream function wizard. As long as you set up an HTTP request, stream HTTP client producer, and then you put in the URL, copy and paste that URL into there, get method, and the target is our inbox. I won't hit OK because I've already set that up over there. And you'll see that's how I have these values. I'll just minimize these sheets. So you'll see these values are actually updating in real time. And this is, if you've ever used Microsoft Excel or Google Sheets, this should all be very familiar with you. You don't really need any coding experience at this point forward. So if you're, let's say, a building manager with no software experience, it's still very simple for you to set up your own kind of dashboard with relevant information. I'm just going to drag, make a very simple bar chart. So our temperature and humidity values are from an HTTPS data stream, but our occupancy data, that's actually, I set that up using MQTT. There isn't actually any occupancy sensor right now. I just have a Python script printing out a random value from 0 to 10. But it's just to showcase that Streamsheets is capable of taking in data from HTTPS and from MQTT and using it on one dashboard like this. So that really solves that issue of having multiple different communication protocols, but having it all easily manipulatable in one place. For MQTT, this is how I set up the MQTT sheet. I have it as an MQTT consumer that's set to listen for the occupancy topic. So that's why it's updating whenever it receives a new message. So you should see that our bar graph is updating in real time as the values change. The red represents humidity, The blue represents temperature and the yellow represents occupancy. But since the occupancy is a fairly small number compared to the rest, it's hard to see it. But at least we can visualize it here on the left in its cell. I'm going to just take a warm breath on the sensor. You should see the humidity jump up close to 100. There you should see that the sensor values update in real time. This was a pretty straightforward demo, but I think it serves as a straightforward look into how you can maybe incorporate Eclipse Lesson, Zephyr, or Streamsheets into your future IoT projects. If you have the time, I encourage you to give the demo a shot, try running it. And if you want to see more content like this, consider subscribing to the channel, or check out our past demo videos. Thank you for watching.